right, thank you everyone. My name is Jorge Teixeira. I am a researcher at Instituto Construção, which is an interface institute with the Faculdade de Engenharia da Universidade de Porto, Porto University in Portugal. It bridges academia and industry policymakers. I'm also a research affiliate with CONSTRUCT, which is a research lab on the departments of civil engineering, also in the University of Porto. And I'll be talking about a case study involving an update or an upgrade of an existing construction information system. How did we manage to glean some more information based on classification to make it more, construction 4.0? Okay, so it's a very standard presentation format, introduction to the case study, then some analysis of the technical content, and finally results and conclusions. So, case study. There is this program in Portugal, a mobilizer program, REV Construction, Digital Construction Revolution, that provided the opportunity to update this ProNIC platform. ProNIC platform is the case study, as you can probably guess. I'll be talking about it a little bit more on a few slides. And it's an overhaul, so we'll be updating the user interface, user experience, the technical content within it, and of course, the data structures that are the basis for the whole thing. All right, so the focus will be on the data structures, not so much on the computer science side, but more on the more generic way of how do we organize the data. For this whole construction 4.0 idea to work, we need data that's properly organized, and we need it to cover the whole life cycle of the building developments. And it's not enough to just keep just throwing data at it over and over. It has to be data enrichment. The new layers of data need to be properly connected to the existing ones, so that as you go through the stages, you'll eventually end up with the information elements of the build object within CDE, Common Data Environment. I'm sure you've heard of it on a few presentations already. That's really usable and interoperable. That's the goal. All right, so the ProNIC platform, that's the main thing here. It stands for Protocolo para a Normalização de Informação Técnica de Construção, which roughly translates from Portuguese to English as Technical Construction Information Standardization Protocol. So, standardization being the operative word. The main goal of this project that was government funded, it started in 2007, and quickly, really quickly, had to go from a sort of academia experimental research project into full-blown production mode. Because between 2009 and 2015, a public company called Parque Escolar, which was recently renamed because it gained new powers, but at the time they were responsible for an unprecedented large-scale renovation of the schools in Portugal. So they liked ProNIC. They said, yeah, now just add a bunch of features on it. We're like, oh, okay. So it's a collaborative IT platform. It provides the integrated management of construction works. It's really big, really broad, but unfortunately we only have the time to focus on some of it, namely within the design stage. As for the technical contents, the focus will be on the work breakdown structure, construction works, which is basically a hierarchical tree-like standardized list of construction works that's going to be used to create the Bill of Quantities. And there's going to be some details about the Portuguese view on what the Bill of Quantities should be. But I guess I can basically summarize it as the Portuguese government mandates a certain detail on the Bill of Quantities. It's not enough to just kind of list the materials. You have to, in a short way, explain what the construction work entails. So you're actually building a wall, not just bricks and add some cement and water. So it's a little bit more detailed than perhaps some of you are accustomed when you hear Bill of Contents. We also have like technical specifications regarding materials, the execution of those works, costs, and of course, we already have a data repository that can be seen as a common data environment. So focus, design stage, WBS-CW, and the platform, like I was saying, hinges on that work breakdown structure. You can probably not see it very well, but that's just a portion of the tree. It's literally a tree. It's organized on chapters, where each chapter is kind of like, not quite a discipline, but you'll have something like foundations of concrete, wooden structures, you'll have landscaping, you'll have construction site management. It's really very, very wide. Everything related to construction has a place on the tree. And as you go down the levels of the tree, you'll come up with the actual work item, okay? That's the key element here. And there's an example here, which is in English. And execution, ground floor, normal grade reinforced concrete with, and then you see those dollar number thingies, which we'll come to in a bit. So that's kind of like a representative way of the level of detail that each entry on the bill of quantities should look like. Now, those dollar signs represent parameters. This is information that the design team needs to add as they are building the bill of quantities. Again, mandated by Portuguese law, has to be specific enough. So for a sense of the scope of the ProNIC platform, we have 26 chapters. Those are like the starting points for the tree. They've been sort of grouped into 12 partitions in a way to combine like related chapters, 6,700 items per se, 41,700 parameters, 2,400 of them are distinct, and 125,000 admissible values, which are basically, think of a combo box for those dollar signs, and you can select only from some predetermined values. On a few cases, you can actually just write your own. So the ProNIC platform, very big. We're only focusing on a small portion of the design stage, which is the bill of quantities. And in terms of the design methodologies that we are addressing, we want to make sure that we get towards, the future, BIM and all that fun stuff. But we need to have a few things in mind. First, that BIM is more than just a 3D model. The design will require different types of information. It needs to be self-consistent to reduce ambiguity. And also, interoperability does require standardized information. The current process that we have with ProNIC, you can kind of see it as, focusing on the bill of quantities. There's something that goes after, next stages, we're not focusing on that. And something that comes before, some vague conceptual design. And the idea is that the design team will select the items from the list, enter all the parameters, set quantities, set prices. Is there more items? Yes, keep repeating it. And eventually, they're done. And now, ProNIC already has the automated ability to consolidate that information and come up with integrated bill of quantities, okay? This is a manual process by the design team. They don't like it very much. Well, they like it because it's better than what they had before, but they would love to have something more automated. If we had something that's BIM-based, so now we have traditional BIM-based, well, right now they're out of luck. They still need to go through the whole thing. But what about if we see it as modeled and non-model elements? So non-model, okay, same thing, nothing changes. But if it's something that we can extract from a BIM model, oh, suddenly maybe we can automate more of it. And now the whole thing kind of looks like this, where the role of the design team is more to supervise and validate. So this is what we're trying to go towards. And the focus is on these two things, the additional item parameters and the key item parameters. What are those? Well, we'll see in a second. So technical contents, parameters. We want to make sure that we get as much info from the model as possible. that may or may not be possible, but we'll try. And the dollars that you can see on the bottom on the left, those were the original definitions. And what we did, oh, by the way, at the top, the dollars, once they are filled in by the design team, look something like that with actual content. And then we looked deep into the whole thing and it came up with a new encoding. And the encoding itself is not super important, but we wanted to standardize the whole terms. So the classification that we actually did was based on what it refers to are these material properties, element, work, or something else. Is it going to assign some sort of physical property, geometric, constraints about how you do something, location identification? And we divided these basically on what did we think that would be found on a BIM model, that's the key parameters, and everything else should be done by hand. So about integration interoperability, what if we try to use something that's already somewhat more standardized? There was this ISO standard that we're already using for something else for costs that divides buildings into structure, the envelopes, spatial dividers, and so forth. Can we also use that? We'll see. Results. So the analysis of the whole thing gave this nice pie chart where you can see that a lot of the elements are from, a lot of the properties relate to elements and materials. So those are probably, can be found easily on the BIM model. The other ones, well, a quarter, not so much. We also have a Sankey chart where you can see that some of the properties can relate to different domains, what it refers to. We analyze this as well. And these are some partial results. So each of the chapters might have a different distribution, so you should focus on different parameters, the ones that are really more meaningful and are not likely to be found on the BIM model, namely stuff related to work, as you can see on the right for exteriors and fixed and mobile equipment. You're not going to find that on the BIM model. This is the one with the ISO standard, so it's now a different classification, gives you a kind of different view on the same content. It's still the same WBS. You can see for services on the right that a lot of the information relates to equipments or elements, so this is a really good candidate for tight integration with BIM. And finally, conclusions. So we need to look at what we have to plan forward. Make sure we use everything that we have already that's good, so we don't have to reinvent the wheel. We will definitely need some information that we won't find on the BIM models. But some of it is already there, so we should take advantage of it. And finally, the classification helped us both internally on the update process and towards the future interoperability, not just with a model that many of us think of, oh, one IFC file, but why not be a little bit more ambitious? Think about data dictionaries, digital product passports, and so on, okay? That might give us sources of info that would complete the info more about the elements and the materials that you can find on the model. All right, so acknowledgements to our funding, namely the Revit Construction Project and Construct, and I'll be happy to answer any questions. Thank you for attending.